Dear student, welcome to the tutorial on plug flow reactor. Question 1. The elementary irreversible reactions of 2 moles of A plus B to form C is conducted in a plug flow reactor. The volume of the reactor is 650 centimeter cube. The conversion is 75% and the initial concentrations of A and B are 1 gram mole per liter and 0.5 gram mole per liter respectively. The feed flow rate is 8.5 gram mole per minute. The desired conversion is to reduce the conversion to 0.5 and they want to find out what would be the new flow rate. So, using the basic mass balance equation, given as FA naught dXA over dV is equals to negative of the reaction rate. Now, using the equations provided 2A plus B to form C, you can then derive that your reaction rate of A is equals to negative K Ca squared Cb. You can then put this into this equation here to form this equation as shown. Next, since everything is done using the initial concentration, so let's convert whatever we can to the initial concentration. So whatever on the left hand side of the equation is similar, K leaves a constant. So Ca can be expressed as a function of conversion using the formula Ca naught minus Ca divided by Ca naught. If you were to do the necessary manipulations to the equation, you can then get Xa Ca naught is equals to Ca naught minus Ca. Now make Ca the subjects of this equation, you will get Ca naught minus Xa Ca naught. Since Ca naught is the common factor, you can then put it out and 1 minus Xa. So you can express the term Ca here using Ca naught 1 minus Xa. So let's input it into the equation. We have Ca naught 1 minus Xa. But don't forget because there's a square, so let's square the entire equation. So for Cb, you can do exactly similar to the equation, which you will get Cb naught 1 minus Xb. Now, however, in the question, Xb is not given. You need to understand that conversion is dependent on the rate limiting reactants in the equation. So, if you were to understand this equation, it means that 2 moles of A will react with 1 moles of B to form product C. Assuming we have the same initial amount of reactant A and reactant B, eventually A will be used up first. Therefore, the conversions of this whole equation will be dependent on Xa or reactant A. So this value here for your conversion for Cb naught can be changed to A. And then you can combine the equation to form the formula Fa naught dXA over dV is equals to K Ca naught Cb naught multiplied by 1 minus Xa to the power of Q. Now you can input all the numbers that are given in the question as such. So using this equation, eventually you will find the K value based on the conversion of 75%. After which, you will use the K value that you have found for part 2 with a conversion of 50% to find out what would be the molar flow rate of this entire system. So with that, you will now have to do your integration. So first, you have to bring your 1 minus Xa cube to the bottom of the equation. So you get dXA. And then you can bring your dV over to the opposite side of the equation. So let's just multiply all the numbers that we have known into the equation so that it will be easier to solve it. So you will get K 0.588 integrating dV from 0 to the volume V, and then conversion is from 0 to 0.75. Now the next most important thing is how do you solve the integrations of 1 over 1 minus XA cube? So first, you need to understand that it will be very difficult for you to solve the equation this way. So let's introduce an artificial variables, u, and we let u to be equals to 1 minus XA. In this case, du will be equals to negative dxa, because when you differentiate the constant 1, you get 0, and then when you differentiate negative xa, you get negative dxa. Now with that, you can now introduce the new term u into your original equation here. So therefore, you will get integration of 1 over u cube, and dxa will be then equals to negative du. To make it easier for visualization, let's remove the negative from the equation, the main equation, and put it on the side. Then with that, you can do your integration. You are essentially integrating u to the power of negative 3. So then you will get the final answer of 1 over negative 3 plus 1 will give you negative 2. You have to divide it by negative 2. And then u square. So this will be your final answer for this integration. Now don't forget, because initially we started off with 1 minus XA. So you have to input it back as 1 minus XA so that you're consistent. So this negative sign here and this negative sign here can be removed. So let's just remove it. So then this equation has a final answer to be 1 over 2. Our u is 1 minus XA square. With this, we'll put this equation back to the original equation. We will get the equation as such. Now integrating of dv will give us a v. With that, you now have to input the two limits into the equation, and you will find that if you were to input 0.75 into the equation, you will get 8 minus, if you input 0 into the equation, you will get 0.5, and then you get k 0.588 and the volume. The volume is given as 650 centimeter cube. So if we were to convert it back to become liter, you will get 0.65. Now therefore, you can solve, and the k value will be equals to 196.23 liter square per gram mole square dot minute. Now this is not all. Remember, we are going to use this k value to solve if we were to have a conversion of 50%, how will the flow rate looks like. So now the conversion has been changed to 50%. So since everything is about the same, we can always use the equation after the integration has been done. However, do note that this value here, 0.588, is inclusive of your initial molar flow rate. So you have to split the equation so that it doesn't include the initial molar flow rate. So essentially, the same equation can be applied, but the conversion now becomes 0.5 is equals to k value is what we have already found, which is 196.23. So we can just put it into the equation. And then remember, this term 0.588 consists of the 1.0, 0.5, as well as when it's divided by FA naught. So let's just put everything into the equation as per it is. So you have 1.0, you have your 0.5, and then it is being divided by FA naught, and then of course your volume, which is given as 0.65. Now you can solve for your FA naught. So you have 2 minus 0.5 is equals to 63.775 divided by FA naught. So therefore, you can solve that your FA naught will be equals to 42.5 gram mole per minute when the conversion is 50%. Question 2. In a wastewater treatment plant, activated sludge treatment occurs in a cylindrical plug flow reactor, 100 meter in length and a diameter of 1.5 meter. If the influence concentrations of BOD is 250 mg per liter, the flow rate is 60 meter cube per day, they want to find what is the effluent BOD concentrations. Given that the BOD remover is a first order reaction with a rate constant of 2.3 per day. So similarly, you have to first use your mass balance equation. Your molar flow rate FA naught is equals to your volumetric flow rate multiplied by the initial concentrations of A dxa over dV equals to, in this case, because it's a first order, so negative RA equals to KCA. With that, try to convert the CA to become CA naught so that it's easier to manipulate the equation since the equation works in conversion. So similarly, your CA here will become CA naught 1 minus XA. Now note that the CA naught and the CA naught on both sides of the equations can cancel out each other. With that, you just have to rearrange the equation so that it's easier for you to do your integration. So this will be the final equations after you manipulate it. Now, so next we need to move on with integration. So you need to integrate 1 over 1 minus XA. Similarly, it will be very difficult for you to integrate it this way. So let's introduce a parameter U to be equals to 1 minus XA. With that, du will be equals to negative dxa. Put it back into the equation, you will get integration of 1 over u negative du. So integrating of 1 over u, you will get ln u, and then don't forget because of the negative sign, so your final answer will be equals to this. And then you have to input the u back as 1 minus xa. With this, we can then input the equation back to our original equation here. So what you will get is your negative ln 1 minus xa is equals to, not forgetting, it's from 0 to xa, the conversion. And then the value of k and qa are provided as 2.3 and 60 respectively, and multiply by the v. So if you were to rearrange this equation, input your xa into the equation, you will get negative ln 1 minus xa, and then if you input 0 into the equation, you have 1 minus 0, ln 1 will give you 0, is equals to 2.3 over 60, and the volume V you can find using pi z squared over 4 and height. So diameter is given as 1.5, height is given as 100. You will get a value of 176.71 meter cube. Input it into the equation, and then you will get ln 1 minus xa is equals to negative 6.77388. Then you solve your conversion. The conversion will be equals to 0.999. With that, they ask, so what is the concentrations of Ca at the outlet? So therefore, it is equals to Ca naught 1 minus Xa. And Ca naught is given as 250 with a 99.9% conversion. Your concentrations of A at the outlet will be equals to 0.25 milligram per liter. Part B wants you to convert this to become ppm. So since this is a liquid system, your milligram per liter and your ppm will definitely be the same. So it's equals to 0.25 ppm. Now part C says that assuming ideal condition, which reactor, a PFR or CSTR, will require lesser volume to achieve the same conversion. So what you need to do is, given all the parameters, now you have to assume that you are running this system using a CSTR. So using mass balances, the flow rate into the system is 60 meter cube per day. The concentrations into the system is 250 milligram per liter minus, assuming similar flow rate out, so you have 60 meter cube per day similarly, and then the concentration out with 99.9% conversion is 0.25 milligram per liter, and your reaction rate here is given as a first order reaction. So the K value is given as 2.3, and then the concentration A, we found it to be 0.25, multiplied by V. So if you were to solve this entire equation, you will find that V is equals to 26,060.87 meter cube. With that, you can then conclude that the CSTR will require a larger volume than a PFR for the same conversion. We have come to the end of this tutorial. Thank you for watching.